Okay, stop! So happy to see you all, your bright, smiling, wonderful faces. Now, let's address the elephant in the room. Not that bad. I gotta be honest. As I walked around the room Friday, I thought you were doing better. But you weren't.
You were wrong.
I got it, and I gotta be honest. At some points, I went, "How did they even come up with this?" Like, I don't even. They invented this. This ain't even close to what we did.
They didn't have the math to do it, so they made it up.
Hey, if you don't have numbers, get numbers.
You gotta make numbers.
I'll tell you what, that's some philosophy some people live by. So, dressing the elephant in the room, that was your first quiz. Now, all that material is fair game forever. Does not go away. The reason behind that as to why. It's not leaving. It's here to stay. It's like your best buddy. It's always there. And all those little tricks you learn in Mr. Hall's back pocket. Always ready to pull one out. Alright? So today, I want to talk to you about a very fun idea. So we talked about isotopes, right? Thank you. Yes, we did. Hold on. I need a green marker for today. It just fits the mood better. You'll see why.
Because we're about to be sick.
No.
No, we're trying to save the planet.
Yeah, green skin for green.
Oh. Aha!
I actually wrote on this
All you gotta do is write on with a dry erase one.
Yeah, I know. I freaked out real bad real quick, and then I thought, oh wait, how am I gonna get this out?
So today, you're gonna see why I picked green. Because when I say this word comes to in your mind, it probably comes green. I don't know why I associate with it. Maybe somebody can explain that.
We are taking psychology.
You want to talk psychology? I hate psychology.
How could you hate psychology?
I'm almost with you there, honestly. Rather easy.
Radioactive isotopes. I always like to cover this idea because it's something that you've probably come into a chemistry room and you're probably wondering, I like you to learn some stuff that answers questions you've already asked yourself as to why. So, why are things radioactive? What's it mean that it's radioactive? What's going on for it to be radioactive? What's taking place? So this is what happens. Radioactive isotopes are isotopes of elements that are unstable. I'm going to show you how this comes to be. So, there's this idea. If I wanted to find out how old something is, and it's dead, but it once was living, everybody gave me a look like, you said dead. Yes, things die. No, it happens. Like, whenever my wife's tomato plants are done for, and I rip them up and I throw them in the creek, they dead. They come on now. Done for. She asked me to do that for all y'all go, oh my gosh, Mr. Hall. I feel like everybody's like, blah, today. Everybody okay?
No, it's been rough. Tired, man.
We need this class like third period.
I'm so sorry. You have it first.
No, I think second period would be better.
No, third period would be perfect.
So, if I want to find the date of something, how old something is, there's this idea called carbon dating. Does Anybody know what occurs with carbon dating?
Carbon dating is the study or basic estimate of how old a substance or ancient piece of architecture or ancient weaponry or any sort of ancient material is based upon or used, such as if we would find a ancient virus in the glaciers of the Arctic, we would have to estimate how old the virus is in order to determine what century it was even created.
Beautiful description. What do we use and how do we do it?
We estimate each individually using Erlenmeyer flasks, beakers, different kind of chemicals, and test what is what, like if one is radioactive.
Just
if one
focus
is
on one
poison.
thing there.
Carbon within the thing.
If you had me for biology,
That's what I'm telling you.
you should know that.
Carbon. It's
Carbon.
14.
Thank you. Carbon 14. Carbon 14 is a radioactive isotope. Now, does it harm us? No. Because that's all based off of what type of radiation is being released. I'm not going to go into that yet. That comes more than likely next week or the end of this week. Somewhere throughout, it's coming soon. You get to learn all about radiation, electromagnetic radiation, and what comes off of it. So if something's releasing like alpha rays, beta rays, stuff like that, not harmful to me. Gamma rays, woo, back up. Son, you crossed the line, you dead now, and you don't even know you dead. But you are dead. You done died, you done killed everything, but you dead. But you don't look dead because it ain't nothing happened yet. But it's happening, and you're going to die. All because of what gamma ray does. It destroys the DNA, which we'll get into. I'm about to go on a soapbox that I don't need to get on because I'll get on it later. Carbon 14. Carbon 14 is unstable. Why is carbon? What makes carbon 14 unstable?
It's a radioactive isotope.
Radioactive isotope. So what about carbon 12?
It's not. It's stable.
Nope, stable. What about carbon 13?
No, it's stable too.
And it's stable too. But carbon 14 is radioactive. So this is what happens with isotopes that are radioactive. They get unstable. And they don't like being unstable. So they're kind of bouncing around. And they literally will just break apart. And this is what's happening with radioactive isotopes. I use carbon 14 for example. So me. We'll take me for example because anytime I say death, it probably should involve me in the room so that not everybody goes, oh my God.
I don't know, I'll accept.
No, sir.
Oh, no.
Dalton.
You would definitely watch Hunger Games.
I'm bored.
Last time I watched the Hunger Games was literally first grade. When it came out.
Oh my God.
And the only part I remember,
Don't worry about it. We got it.
my tooth fell out. That's the only part I remember about it.
Okay, anyway, so me for example, what do I do on a daily basis? And it's not rubbing my belly.
Necessities.
Eat.
I eat. So what is my body taking in?
Energy.
Yes, energy.
Glucose.
But what's in there, element-wise?
Carbon.
Carbon. So part of carbon, carbon 12, carbon 13, but carbon 14. Carbon's carbon. Body doesn't, these molecules and stuff don't tell the difference. They're just like carbon, 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 carbon. Okay? So carbon 14 is coming in. Now, perfect. What happens if
You release the carbon.
you don't know what this means?
I'm plumb depressed.
I die.
We push you away on the boat and light you on fire.
Listen, don't worry. Please do that. It was the most epic thing ever.
We didn't sing Hark the Herald Angels Sing. I know that song's been stuck in my head.
Okay. Okay. What happens then? Am I eating?
No.
No, so I'm not taking carbon in.
You're releasing.
The carbon, 14, starts breaking down because it's unstable. What happens is it breaks apart. So like uranium, plutonium, they all go off the same idea. Only difference is, once they break apart, they also release energy, which is in forms of radiation. We'll get to that later, don't freak out yet. Yeah. So what happens is the amount of carbon-14 that's in my body, to start with, starts breaking down. This is how we can do what's called carbon dating. Someone can come in, take a sample of me, examine how much carbon-14 is in me, and they'll say, hey!
He's not completely decomposed.
Yeah, well, yeah.
Common sense tells you that.
Okay, 100 years from now, they'll find me. Okay, let's go with that. Because your Viking send-off, it rained and it didn't work.
Wait, an element can be alive
We'll
for
say waterfall and you just
years.
It's all about the half-life. So this is what they're going to use to work backwards to date me whenever they find me. And by date me, I don't mean they're going to take me out to Chili's in a movie. So,
It's like an old crumble up course and chili. You just sit there and say, would you like some soup, sir?
you say that all the time about good soup. So, this is what's happening. They can now look at the amount of carbon-14 that's left in my body and work backwards to date me. This is what's happening within artifacts we find, within all sorts of life, everything around us, everything we run into when we're dating something. Carbon-14 is an excellent example of this. Now, we'll use carbon-14 in things that are alive, like trees. We find some old fossilized tree, you're like, hey, see how old this baby is. We can do some carbon-14 dating. So we take it out to Chili's, take it out to a movie, and then we find out how old it is. Capiche?
Aren't you supposed to do that before the date though, so you don't catch a case?
Probably.
That's not very smart, Mr. Hall. Some 14-year-olds look 28 these days. Just saying.
14-year-old.
Look at some of the freshmen.
Okay, now,
Some of them look like they were 32.
today I will bestow upon you knowledge like you have never seen before. Greatness is about to come your way. How many of you have one of these?
Oh my goodness.
How many of you need one of these? Very guys. They are somewhere in my mess of a desk. If you need one, raise your hand. Hello. 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 Reach that just back. Hello. Everybody else got one? You need one. Now, Mr. Hogg is not going to do his on there. Mr. Hogg is going to do his on here. So, there is this lovely thing we like to use. It was a good example because I asked you this question. What is the international system of unit for the amount of substance?
Mole.
The mole.
Not miles.
That's right.
You guys remember Austin Powers? Molly.
So today,
I don't get these references you people are using.
Well, be more cultured.
Yeah, I got one.
we do the moment. So, the key word is mom. I'm going to go on a day. No matter what you do, give me a second. This one always takes a while. Articles, molecule, formula. always techie wise. Never fails.
How are the biology books?
See, there's one right under Elijah's desk. Just take it, bring it back.
Alright.
So help me if you do not bring it back, we will find you and ask for our book back.
Thank you.
You're welcome. So, the key in doing this, and this is a map. Mole map. Thank you, I'll take that back. Mole map is your roadmap to success when doing mole conversions. If you can get this down, you'll be golden. So here's the thing you're going to deal with. There's 4 different areas. And it's all about destinations. Where you're starting, where you're going, how you're going to get there. This will drive you to an A. And if you cannot drive the map, well, you can't stay up. So make sure to drive the map. You have maps. Now, I have this question for you. What is a unit for mass?
Kilogram.
Kilograms. Perfect example. You know what? Wonderful job. I just love that. Kilogram. You know why that's so good?
Really like kilos.
Yeah, but it's not kilogram. I can do micrograms. I do grams. If I ever just felt like it, just for the fun of it. Gigograms.
We can do milligrams.
I do milligrams. It's always going. Remember how Mr. Hall told you what you learned? Don't forget it. Guess what? I can put any prefix on gram I want for mass. And guess what you gotta do?
Got to figure it out.
Start with
Drawing the map.
metric. Conversion. Beautiful job.
Oh my goodness.
You know what the bad thing is? Mr. Hall no longer spells it out to you. I no longer look and say, hey, yo, how many of this is equal to this? I look at you and I just give it to you. And you go, whoa, I got to do a metric conversion. You got to be on your toes. And this is as to what? Where you're going to find this mass. It depends on what you're dealing with. So, it can be an element, it can be a molecule, or it can be a compound. It can be several different things. So this is where another useful piece to have out with you is one of these. Everybody got one of these? This is the periodic table. Come get this. Who want this? This is a gift from me. You know, I've gave you about, what, 60,000 yet? Off the periodic table is what you're going to find. On the periodic table is a beautiful concept for you. You see that average atomic mass there? These things are interchangeable. It's literally set to that's how many grams is in 1 mole. That's how this works. It's kind of like whenever you go to the grocery store, and if you're living fancy, and you walk up, and you're like, hey, yo, you don't say, can I get 23 slices of that ham? You look and say, hey, can I get a pound of that ham? I get a 1/4 pound. Can I get half a pound? You give them a measurement. That's what the mole concept is. It's going to take what you're going to see as really large numbers and make them smaller and easier to deal with. Don't be so intimidated by it. If you get the mole map, you'll be fine. Just flow with it. So a perfect example is you can go from mass to moles. So let's say I want to go from mass to moles. I'm going to use green. You have to set up conversion factors. Now, the conversion factors are not that difficult. But what you're going to is what has to be on top. That's right. You're going to deal with fractions in here. Nobody freak out. Bless you.
Thank you.
So we're going to have a fraction. On top will be what you're going to. So I'm going to mole. In this case, it's 1 mole because that's the conversion factor. On the bottom,
So it will always be 1 mole.
in the conversion factor, yes.
Okay.
There's this blank. And that's where the mass comes in. Off the periodic table, it is set to that number. So carbon, for example. I want everybody to look at number 6. That's carbon. Everybody look on your periodic table. See number 6. Do you see the average atomic mass of 12.01? That is 12.01 grams per mole. So this is grams. This is where units matter and why they're so important. If I start you in kilograms, what are you going to have to do?
You're going to have to do a metric conversion.
You're going to have to do a metric conversion to get the kilograms to what?
Grams.
Grams. I will not spell it out for you. You have to catch it now. Now this blank, that's the beauty of what we're looking at. No matter what, it will come from the periodic table. I'm just going to do PT. It has to come from the periodic table, unless I give you a problem for an unknown element. I give you its isotopes and its percent abundance. Because what can you do with the mass numbers that come with the isotope and the percent abundance?
All the average mass.
You can find the average atomic mass. So this will come from the periodic table. Keys to know. On the periodic table, it is grams per mole. I'm going to add something here, and we're going to do it later, so don't freak out on me. Looking at the time, it may happen tomorrow. If molecule / compound use periodic table to find molecular mass. Now I get molecular mass is probably something you guys have never heard of before. That's okay. Don't freak out about it. I want to show you tomorrow, probably, hopefully I can today, but we may tomorrow, of how you're going to find that and how that information is useful to you. Now, this is the interesting thing with the mole map. If I decided that I was going to take my wife out to the Chili's, to the movie, where's the closest Chili's? So I'm going to take her to Beckley. So here's us in Copperston. I go to Beckley. Now, do I live in Beckley?
No.
Well, Mr. Hall's getting old. Mr. Hall likes sleep. So what do? Got to do so I can sleep? I got to go back home, right? So guess what you can do?
Go home.
I can go from Beckley and go home. Now, here's the thing. Where am I starting and where am I going to? I'm starting at moles. I'm going to mass. So this conversion factor has what on top?
Grams.
The grams. What's going to go on the bottom?
1 mole.
1 mole. Nice job. This will cancel the moles and leave me with mass. And remember, the blank comes from the periodic table. Even if it's not directly off the periodic table, you will use the periodic table to find it. So that's it for the first section. Very simple, yes? Very nice. I always love to let kids get involved in the class. So now we're at Beckley. Now we got to make a decision. My wife is a woman, so you know she can never pick a place to eat. It's impossible. Okay? Men, greatest lesson I can ever teach you. If a woman looks at you, oh, I don't care, you pick. She's lying. There ain't no truth in that statement whatsoever. It's a trap. Don't fall for it. Because if you pick wrong. If you thought last week we had Olive Garden and Italian, so we definitely need to do barbecue today. About halfway through your meal, and you're halfway through your barbecue, like, man, it's barbecue, man. It's not. It's busted.
I don't like it. I get Olive Garden with big bad.
You get to hear that.
This is what you're going to get. You're that's when you know you messed up.
I really like it.
That was woman talk for you made the wrong choice. Why'd you pick here? And every man's thinking the same thing. I thought, you let me pick. You said you didn't care. Because a man's brain thought, I don't care, means you don't care. And you're going to hear halfway through it, no, this is okay, but I really could have went for Olive Garden. Then why didn't you pick there?
Well, we got it last time. I didn't think you wanted it.
That's when you're supposed to say, guess where I'm taking you in the first place. Say, guess
Does not work, it's a lie. It's a flat out lie. Because now whenever a guy does it, you know what he hears? It's like,
You saw that
oh,
on
no, you can't. Exactly, you saw it on TikTok. I know what you're doing.
Oh,
And then they're not happy with it anyway.
oh my
They're not happy with going there either.
I don't know what type of women y'all are dating and they're married to, but Jesus.
I'm married to an incredible woman.
Oh, does she really get mad at you?
Eat that.
Or no, she don't
Eat
get
that.
mad. Listen, I got so smart in 6 months of marriage, I figured this out. If I was going to Beckley today, I would have already texted her and said, where are we going to eat? Because I'll find out by the time I'm almost home.
Exactly.
All right, so you choose. Where are we going to go? We're in Beckley. We got our 2 restaurants. I know there's some women in the room. I need you to choose.
Oh, no, not again. All right.
I don't know.
All right,
We're going to go to
We went there.
To
we went
Clyde
there
and
last time.
What?
So we're going to go to Casa de Volume or APMF. One's Italian, one's a coffee shop.
You pick. Are you ready?
APMF coffee shop.
No, you're a man. Your opinion don't matter.
I wasn't ready for that. Okay, so we'll go here.
Ha!
It did matter.
Well, nobody spoke up. Did you notice no women said anything? You all can message my wife and tell her I'm saying it.
She'll just watch on YouTube if she wants to, bad enough.
Somebody in here is going to message her and she's going to text me, like, are you talking about me?
Go back, check out first period.
Then she'll never ever pick again or tell you what she wants.
Oh no, she will. Trust me, she'll get hungry enough. She'll pick. I'll stop at a gas station and grab a snack. Alright, so we're going from moles to atoms, particles, molecules, and formula units. This is simple. Super simple. Don't get caught up on whether it's atoms, particles, molecules, or formula units. You want to know why?
Because it doesn't matter.
It matters.
Units
You
always
said that a
matter.
lot, so I'm just pointing it out.
I get you. I get you.
Units still matter though.
They do matter.
Those are.
But guess what I'm going to do? I'll either start you here, so if I start you here, don't I have to start you with the units?
Yeah, that's true.
Because if I don't, can't you look at me and say, Mr. Hall, units matter. Look at you.
Yeah,
You took points off my quiz because I didn't put units. And now you ain't putting units.
I'm taking it.
Okay? I start you here, right? So I've already gave you the units. Let's say I start you here, and I ask you to go here. What am I going to have to do? Give you the units.
Probably.
Yeah. So it doesn't matter. It's atoms, particles, molecules, and formula units. In your brain, just wrap them all together.
I mean, you still got to remember. Anyway.
All right? Wrap them together, hold them together. Here's the most simplistic one, but it's the one that students struggle with the most because of a certain number. We have a conversion factor. So I'm going from moles to atoms, particles, molecules, or formula units. What goes on the bottom?
Mass.
Not quite.
Mole.
Mole. Are you finding a pattern here? There's a reason it's called
Yes, stress.
The mole.
mole map. There's a reason it's called mole conversion. What are you going to find common in every one?
Mole.
Now, here's the thing. All of these units can fit right there. It can be atoms, it can be particles, it can be molecules, or it can be formula units. But like I said, I will give that to you. I'm either giving it to you for you to start with, or it's literally the question. I will ask, how many particles, how many molecules, how many formula units, how many atoms? Just read the question. You'll find where I'm trying to get you to go.
What's an example of a question to find some of this?
Let's not get there yet. There's a special number. I'm going to show you the abbreviation of this number. And this number is so important I have to change colors. I must use purple because it's super important. The number is abbreviated with a capital N and a sub-capital A.
So,
And that's why I did this. Capital N, little capital A is Avogadro's number.
is whose?
Avogadro's number.
Our handwriting number.
Avogadro's number.
That's not Avogadro's hashtag, that's Avogadro's number. And I may have spelled Avogadro. Doesn't matter as long as you know what it is. Because I'm going to answer just like all y'all. Does spelling matter? Because I'm going to tell y'all right now, y'all suck at spelling Erlenmeyer.
Oh, you're telling me.
Yeah, y'all butchered it. But it's okay. You know what you were talking about. I gave it to you.
Somebody could have put Oscar on that.
Hey, to be honest with you, I probably couldn't spell Erlenmeyer either.
I feel like
It's okay.
Flash could be funny.
Avogadro's number. Here's the thing. This is Avogadro's number. 6.022 times 10. Remember what Mr. Hall said. We're taking really big numbers to small, right? You're going to see how big we're talking. To the 23rd power. And this is
That's a big old number.
atoms, particles, molecules, and formula units.
What's that little line symbolize?
What line?
The horizontal line right beside Avogadro.
That's the space for all those units.
Avogadro's the number.
I do have some kids that can't do Avogadro, so they say avocado. I find it funny. Now, just like before, I took my wife to the movies. We're going to go back somewhere in Beckley, right? We can go both ways. It's a map. Okay?
So you have to go forward, backward, backward, forward. Wait.
Oh, wait.
No, you can.
Conversion factor. Don't freak out yet. That comes later.
Okay.
Just prepare yourself.
What goes on top?
Mole.
Mole. Why is mole on top?
Because it's a reciprocal.
I'm going to mole.
It's
Simple.
the same thing.
Hold up. What goes on the bottom?
In a added particles restaurant.
Precisely.
That goes on the bottom. Here's the thing. Last thing I want to add. Avogadro's number is not sodium.
Yeah, I know.
This is Avogadro's number. This is sodium. What's the difference?
The big
Look
A and the
at it.
little A.
The capital A or lowercase a. We will finish the mole map tomorrow and start in on them. All we have left to talk about is the volume. Have a great, wonderful day. It was wonderful seeing you all.